Okay, so for this video, we will be discussing the second method in finding the volume of solids of revolution. So the second method is called circular ring method or the washer method. Okay, so in this method, so say for example, we have here an area enclosed by two curves and revolved around a certain axis. Okay, so the circular ring method, similar with the circular disc. Okay, the differential volume that is formed from the revolution of the strip will form a circular ring. Okay, so say for example, so we have this area and then it is revolved around the axis. So if we if we revolve this strip around this axis, so it will form a ring. Okay, so say for example that is our ring, so it is hollow inside. Okay, so it's hollow. Okay, so this is a circular ring. Okay, so a ring, or it's also called a washer. Okay, so in finding the differential volume of that ring, so the differential volume is equal to, from the volume of a ring, it is equal to pi multiplied by outside radius squared minus inside radius squared multiplied by the thickness. So in this case, so we have dx, okay, as the thickness. So where the outside diameter will correspond, the outside radius will correspond to this length. Okay, so from the axis of revolution until the higher curve. Okay, so that is our O. And the inside radius will correspond to the distance from the axis of revolution to the lower curve. Okay, Ri. Okay, so its general formula, therefore, if we integrate both sides of the equation, so it's equal to V is equal to pi integral of outside radius squared minus inside radius squared dx. Okay, so this is the general formula for circular rings. Okay, so this is for a vertical strip. So if it's a horizontal strip, then V is equal to pi integral of RO squared minus RI squared dy. Okay, so as you can see from the graph, so we use a circular ring, okay, or we use the washer method if the strip does not touch the axis of revolution. Okay, so the first condition is the strip is perpendicular. Okay, it's perpendicular and doesn't touch the axis of revolution. Okay, so it's that. Okay, so generally if the case is this, then we use the circular ring or the washer method. Okay, so let's solve some examples involving this. Okay, so for our first example, so find the volume generated by revolving about the y-axis, the area bounded by the parabola x squared is equal to 12y, and the line x is equal to 3, and the x-axis. Okay, so let's graph that. So first one is we have here a parabola, x squared is equal to 12y. So this is a parabola opening. This is parabola opening upwards. Okay, so we have a parabola opening upwards, like that. So the line x is equal to 3. So let's say x is equal to 3 is this, a vertical line. Okay, and the x-axis. So we are concerned with this area. Okay, so this is now revolved about the y-axis. Okay, so it will be revolved around the y-axis. Okay, so you can now imagine, so how will it look like? So it will look like a bowl. Okay, so if we are going to use the circular ring method, okay, so the condition the strip must be perpendicular with the axis of revolution. So our axis of revolution is the y-axis, therefore our strip must be horizontal. So we will be using a horizontal strip. Okay, so next is since we will be using a horizontal strip, therefore our differential thickness is dy, so therefore our limits later on must be in terms of dy, in terms of y. So we must find the coordinate of the intersection between the parabola x squared is equal to 12y and x is equal to 3. Okay, so all we need to do is substitute x is equal to 3 in there. So therefore 3 squared is equal to 12y. So this will be 9 is equal to 12y, dividing both sides by 12 and simplifying, therefore we will have y is equal to 3/4. Okay. So our point here must be 3 for x and then 3/4 for y. Okay, so from the general formula of the circular ring method, so we have volume is equal to the integral of outside radius squared, sorry there's a pi here, outside radius squared minus inside radius squared dy. Okay, so since we are using a horizontal strip. Okay, so now the outside diameter, so as you can see, if we revolve this here, so the outside diameter will correspond to xr. Okay, so that's our outside diameter. Inside diameter will correspond to this length. Okay, so that length is xl. Okay, or this one. Okay, so therefore this is our xr and then this is our xl. Okay, because the parabola is on the left, so you can see left side of the strip, left end of the strip, and then 3 is on the right end of the strip. So therefore, we will have v is equal to pi integral of, so RO is XR minus RI is XL squared dy. So y is from y is equal to 0 to y is equal to 3 over 4. Okay, so substituting XR and XL so that our integrand will be in terms of y, because we will integrate in terms of y. So our v now will be equal to pi integral of XR is 3, so 3 squared minus XL squared, so we can say here it's equal to 12y. Okay, dy from 0 to 3 over 4. So therefore our v is equal to pi integrating, so this will become 9, so integral of 9 dy, so that's 9y minus 12y squared over 2, so that is 6y squared. So limits from 0 to 3 over 4. So substituting the limits, so v is equal to pi multiplied by, substituting the upper limit, 9 times 3 over 4 minus 6 times 3 over 4 squared minus, we substitute 0, 9y will become 0, 0, 6y squared will become 0. Okay, so you can use your calculators from here. So this is 27 over 4 minus, this is 9 over 16, so 9 times 6, that is 54 over 16. Okay, so this is by LCM is 16 divided by 4 times 27, so that is 27 times 4, so that is 108 minus 54. Simplifying, that will be pi times 108 minus 54, that is 54 over 16. Simplifying 54 over 16, that is, so divided by 2, that is 27 over 8. Okay, that is 27 over 8. So 27 over 8 pi, so this is in cubic units. Okay, so that's how you use the washer method. Okay, so again, the conditions are the strip must be perpendicular with the axis of revolution. Okay, so if the axis of revolution is vertical, then the strip should be horizontal. Okay, so that's it. Okay, so for our second example, so find the volume generated by revolving the area bounded by the parabola 8x is equal to y squared and the line 2x minus y is equal to 0 about the line x is equal to -1. Okay, so again, first step is to sketch the curve. So we have 8x is equal to y squared, so that is obviously a parabola. So since y is squared, Therefore, this parabola is opening to the right. Okay. Okay, so the parabola is opening to the right. Okay, so this is y-axis, x-axis, and then we have the line 2x minus y is equal to 0. So this is a line. So let's transform it into point slope form so that we can see its slope. So we have 2x minus y is equal to 0. Transposing y, we have y is equal to 2x. So therefore, we have a slope of 2 and a y-intercept of 0. So therefore, it passes through the origin with a slope of positive 2. So therefore, it is inclined upwards. So let's say, looks like this. Okay, so this is the line y is equal to 2x, or 2x minus y is equal to 0. Okay, and then this parabola, okay, this parabola is 8x is equal to y squared. Okay, and then the area bounded by those two graphs, so obviously is this part here. Okay, so this is the area enclosed by those two curves. So this area will be revolved about the line x is equal to -1. So let's say x is equal to -1 is around here. Okay, so this is x is equal to -1. So we will revolve the area around this. Okay, so to use the washer method, so again the condition was we draw a strip that is perpendicular with the axis of revolution. So if our axis of revolution is vertical, then our strip must be horizontal. Okay, so that is a horizontal strip, therefore its thickness is dy. Okay, so from the formula, so the formula for a circular ring is v is equal to pi integral of outside radius squared minus inside radius squared, and then dy from limits we don't know yet, so we will need to solve for the intersections. Okay, so obviously this one here is the origin, and then this is the unknown. Okay, so solve for the intersection of, to obtain the limits we must solve the intersection. Okay, so solve for intersection first. So we have 8x is equal to y squared and 2x minus y is equal to 0. Okay, so from here we can say that y is equal to 2x, then substituting that y here, so we will have 8x is equal to 2x squared. Okay, so therefore 8x is equal to 4x squared. So transposing 8x on the other side to solve for x, so we will have 4x squared minus 8x is equal to 0. So we have a greatest common factor of 4x. Then factoring out 4x, what will remain is x minus 2 is equal to 0. So factoring the equating the factors to 0, I mean, so 4x is equal to 0, therefore x is equal to 0, and x minus 2 is equal to 0, so therefore x is equal to 2. So So substituting x is equal to 0 and x is equal to 2 maybe here, so that we can solve for y. So at x is equal to 0, y is equal to, so 0 times 2, 0, and then at x is equal to 2, y is equal to 4. Okay, so therefore this one is the coordinates of the first point, the origin, and then this one is the coordinates of the second part here. Okay, so this is x is equal to 2, y is equal to 4, so therefore 2, 4. Okay, so our limit would be, since we are we have a dy, okay, strip, so therefore our limits will be from y is equal to 0 to y is equal to 4. Okay, so the second problem is the radii. Okay, so the outside radius will be defined by this length. This is the outside radius from x is equal to -1 until here. Okay, so this length, and then the inside radius will be this length. So from here okay, okay, so this length, okay, so measuring this length, okay, will be the same as measuring the length of the strip. Okay, so this distance, so from the y-axis until the right end of the strip, it is defined by this equation. Okay, so since we'll be using x, so let's transform the curves as x as a function of y. So transforming this, transposing y on the other side, and then dividing both sides by 2. So x is equal to 1/2 of y. Also, for this, dividing both sides by 8, so x is equal to 1/8 y squared. Okay, so our outside radius, okay, so will be defined by xr minus xl. So for RO, our xr will be defined by x is equal to 1/2 of y. Okay, and then our xl will be defined by x is equal to -1. Okay, so xr minus xl. So our xr is this one, 1/2 of y, minus xl is -1. Okay, so our r is equal to, outside radius is equal to 1/2 y plus 1. Okay, so similar with the inside radius, so the inside radius will be the xr minus xl. So our xr in this case will be defined by x is equal to 1/8 of y squared, and our xl will still be defined by x is equal to -1. So our ri is equal to xr minus xl, xr minus xl. So xr is 1/8 of y squared, still minus -1. So our inside radius therefore is equal to 1/8 y squared plus 1. Okay, so solving for our volume, so from what we have gathered so far, so volume again is equal to what was that, pi integral of outside radius squared minus inside radius squared dy. So v is equal to pi integral of our outside radius is 1/2 of y plus 1. So 1/2 of y plus 1 squared minus our inside radius is 1/8 of y squared plus 1. So 1/8 of y squared plus 1 squared. Okay, and then dy from limits from y is equal to 0 to y is equal to 4. So from 0 to 4. Okay, so with that, so let's proceed to integration. So we'll have v is equal to pi integral of expanding this using our knowledge of special products. So square of a binomial, so we'll have first term squared, so we'll have 1/4 y squared plus 2 times first term times second term, so 2 times 1/2 y times 1, so we will have plus 1. And then second term squared, so plus 1 minus, so do this expand this similar with the first one, so 1/8 y squared and then squared, so that will become 1/64 y to the power of 4 plus 1/8 y squared plus times 1, okay, multiply and then multiply by 2, so we will have 1/4 so 1/4 y squared, okay, and then second term squared, so plus 1, okay, dy limits from 0 to 4. Okay, so simplifying, v is equal to pi integral of, so removing the grouping sign, so we will have 1/4 y squared plus y plus 1 minus 1/64 y to the power of 4 minus 1/4 y squared minus 1 dy from 0 to 4. So as you can see, we have similar terms. It can be cancelled out, and also the constant. So what will remain is integral of y minus 1/64 y to the power of 4 from 0 to 4. Okay, so next is integrating. So v is equal to pi integrating y dy, so that is 1/2 y squared minus integrating this, so 1/64 multiplied by the integral of y to the 4th is y to the 5th over 5. Okay, from 0 to 4, simplifying, so we have pi multiplied by 1/2 y squared minus 64 times 5, I think that is 320 y to the power of 5 from 0 to 4. Okay, so now let us substitute the limits. So v is equal to pi, so we have 1/2 upper limit 4 squared minus 1/320 4 raised to the power of 5 minus lower limit, if we substitute 0, this will become 0, and then this also will become 0. Okay, so v therefore is equal to pi multiplied by, so this will become 4 squared over 2, 16/2, that is 8 minus, so 4 raised to the power of 5 over 320, so using our calculator, so we can 4 raised to the power of 5 over 320, so that is 16/5. Okay, so simplifying, so 8 minus 16/5, so 8 minus answer, So that is 24 over 5 multiplied by pi, so therefore that is 24 pi over 5. So obviously this is still in cubic units since this is a volume. Okay, so that's it. So the solution is pretty long, I think. So the long part only was the expansion and the simplification, but the integration starts here, so which is fairly easy. Okay, so you have to be very good with your algebra. Okay, so in terms of expanding and simplifying terms. And back to the solution. Okay, so finding the outer radius and the inner radius can be very tricky. Okay, so but all you need to remember is just subtract, okay, from right to left. Subtract the right x by the left x, okay, so that you can get the what do you call this, the length, okay, of the radii. Okay, so that's it, I think, so for this method. So again, for washer method, you need to remember this general formula, okay, and also the condition. Okay, so the condition that your strip should be perpendicular with the axis of revolution, okay, and then the strip does not touch the axis of revolution. So if it touches the axis of revolution, then it's already it can be solved by the first method, which is the circular disc. Okay, so good luck.